Good morning, everyone. So today we're going to venture way beyond the confines of our textbook exercises. We're moving past the standard problems of just solving for X and Y to really explore how a fundamental mathematical tool, one that you're studying right now, is not just some abstract academic concept. No, it's a dynamic force that is actively shaping the future of business, technology, and finance as we speak. So to get us started, let's think about a question that's really going to frame our entire discussion. You see on the screen three distinct but very interconnected fields: artificial intelligence, algorithmic trading, and risk analysis. Now, these aren't just buzzwords you hear on the news. They represent some of the most powerful and, frankly, disruptive forces in our modern economy. So the question I have for you is this: what's the common mathematical language that underpins all three of them? The answer, as we're about to see, is something you're already familiar with from your homework: matrices. And my goal today is to show you that the power and the real-world application of matrices go far, far beyond what you might have imagined.
All right, let's start our deep dive with the first section of our lecture. Right here, we are going to completely reframe your understanding of what a matrix truly is. We're going to move past this idea of matrices as just abstract grids of numbers made for homework problems. Instead, I want you to start seeing them as what they are: dynamic and absolutely indispensable tools used in professional contexts like financial analysis, strategic planning, and technological innovation. Okay, this is the crucial point I really want you to grasp. We have to shift our perspective. Matrices are not just static containers for organizing numbers. I want you to see them as a dynamic framework, a language, really, for modeling the complexities of the real world. Think about it. A business isn't a single variable, right? It's a complex ecosystem of suppliers, customers, production costs, revenue streams, the whole shebang. A matrix gives us the perfect structure to represent this multidimensional reality in a format that a computer can actually understand and work with. For instance, a really simple matrix could show a company's sales, right? The rows could represent different products, and the columns could be different sales regions. Now, that's a basic example, but you can already see how it starts to capture the complexity of a business in a very organized way. This brings me to a really common conceptual trap that I see students fall into all the time. It is so easy to look at a matrix and just see it as a glorified spreadsheet, just a place to hold data. But that is an incredibly limited view. It's like looking at a high-performance racing engine and seeing nothing more than a heavy paperweight. You're completely missing the point. The real, true power of a matrix isn't in its ability to just store data, but in the operations you can perform on it: multiplication, inversion, transposition, you name it. These operations are the engine. They're what transform the data, allowing us to solve huge systems of equations, model complex transformations, and uncover these hidden patterns and relationships that would otherwise be completely invisible to us. And this is where the application of matrices gets really exciting. The terms you see on this slide, AI, machine learning, data science, these aren't just trendy concepts. They represent the most transformative fields in business today. And matrix operations are the absolute mathematical bedrock that they are all built on. You know, when a machine learning model learns, what is actually happening under the hood? Well, it's essentially performing a massive series of matrix operations to tweak the weights and biases of its neural network, which, by the way, are themselves stored in matrices. When an AI system recognizes a face in a photo, it's processing a giant matrix of pixel data through a series of filters, which are also represented as matrices. This is the power of matrix math at work, enabling machines to learn, to reason, and to make decisions. Okay, so let's shift gears from the theoretical to the practical. In this section, we're going to look at exactly how these abstract ideas we've been talking about translate into tangible, real-world applications that literally drive modern economies and shape corporate strategy. This is the point where all that theory from your coursework starts to show its incredible real-world value. This slide here just gives you a tiny glimpse into the vast and incredibly impactful applications of matrices in the business world. So, in computational finance, portfolio managers use something called covariance matrices. A covariance matrix is a brilliant tool that tells you exactly how much different asset prices tend to move together. By analyzing this matrix, a manager can build a diversified portfolio that gives them the highest possible expected return for a certain level of risk. This is literally the foundation of modern portfolio theory. Then you've got algorithmic trading. High-frequency trading firms use matrices to solve complex systems of equations in real time. We're talking microseconds, allowing them to spot and exploit these tiny, fleeting price differences in the market. In risk analysis, banks and financial institutions use matrix models to run stress tests. They simulate what would happen to their entire loan portfolio if, say, interest rates suddenly spiked. And finally, data-driven strategy.
Companies like Amazon use matrices to solve enormous optimization problems, managing everything from inventory across millions of products to figuring out the absolute most efficient delivery routes for their entire fleet. All right, let's walk through a practical example to make this really tangible. I want you to imagine you're a strategic planner for a huge global electronics company. Your job is to decide where to launch a brand new product, North America, Europe, or Asia. The first thing you do is build a matrix. Let's call it matrix C for costs. The rows will be your 3 markets, and the columns will be your key cost variables, production cost per unit, shipping cost, and the marketing budget. Now you build another matrix, matrix R for revenue. This one's a column matrix where each row is the projected sales price in that market. Now, to find your projected profit per unit in each market, you perform matrix operations. But here's where it gets powerful. Let's say a new 10% tariff is suddenly slapped on all your components. You can represent this change as a simple scalar multiplication, multiplying your entire production cost column by 1.1. With one quick matrix operation, you can instantly see the new updated profitability for all 3 markets at the same time. You see, you're no longer just relying on gut feeling or intuition. You've built a dynamic model that lets you make a data-driven strategic decision with real confidence. That's the power of matrices in action. And this brings us to what I believe is the most critical part of our entire discussion today. Understanding how a deep grasp of matrices can directly and powerfully impact your future career. This isn't just an academic exercise, folks. The ability to think in terms of matrices, to model complex problems using this framework, is a fundamental skill that is going to set you apart as a business leader in the 21st century. It's your career superpower. This slide right here, this illustrates the modern strategic decision-making process. It's a loop, and it's powered by matrices at every single stage. Let's break it down. Step 1, data aggregation. That's a fancy way of saying you take all the chaotic, messy, unstructured data from the real world and you organize it into a nice, clean, structured matrix. Step 2 is predictive analytics. This is where you apply those matrix operations to forecast what might happen in the future. This includes powerful techniques like linear regression, whose formulas, by the way, are expressed beautifully and efficiently using matrix algebra. Step 3 is automated optimization. Here, you use algorithms, many of which rely heavily on matrix operations, to find the absolute best possible solution to a problem, like how to minimize cost or maximize profit. And finally, step 4 is strategic planning. This is where you, the human decision maker, take all the incredible insights generated from this process and use them to make informed, high-level decisions. Mastering this loop, from raw data to a smart decision, is what's going to make you an invaluable asset to any organization. So the crucial takeaway here, the thing I really want you to remember, is that your goal in this course needs to be bigger than just getting the right answer on an exam. The real goal is to learn how to ask the right questions of your data. This knowledge is going to transform you from being a passive consumer of information into an active analyst who can interrogate data, model different scenarios, and spot strategic opportunities that nobody else sees. So instead of just asking, hey, what were our sales last quarter, you can start asking, what are the underlying factors driving our sales, and how can we model their relationships to forecast and maybe even influence our future sales? See the difference? I'm going to leave you with this final thought. You are poised to become the next generation of business leaders, and you are entering a world that is more data-driven than at any point in human history. So I urge you, view this course not as some academic requirement you have to check off a list, but as the foundation of your training as a future innovator. The question you should be asking yourselves is not if these mathematical tools will be used in your careers, but how. How will you leverage them to innovate, to create, to compete, and to lead? The future is in your hands, and the language of that future is mathematics. Thank you.